Hello students, a very big hi to all of you from my side. How are you all? I hope you are doing absolutely fine. So, in our previous lecture, we have discussed about our chapter number 4 of the class 10th chemistry, that is about the carbon and its compound, and we have completed that chapter. Now, we are going to start our new chapter, that is the chapter number 5th of the class 10th chemistry, and this is the last chapter of our syllabus, that is periodic classification of the elements. So, you have heard about many type of the elements exist in nature, but in 18th century or before the 18th century only 30 elements are known, but today we are known with 120 elements approx or more than that. So what will happen here? Today we are known with 120 elements in nature. So today 120 elements are available, but in 1800, so we can say that in 18th century only 30 elements are known. So today we are provided with 120 elements, but in year 1800 only 30 elements are known. Only 30 elements are known at that time. So you can see that only a little amount of elements are known at that time. But today we are provided with almost 120 elements. Now these 30 elements are easy to remember their names, and all of they will carry a different physical properties. So it might be very easy to remember such kind of the properties. But what will happen then? As a new elements are discovered, scientists are very much willing to learn about the property of that compounds. So one more problem before them was that how do we arrange the elements and how do we classify the elements? So the biggest problem there was how do we classify the elements. This question, that how do we classify the elements, is the biggest problem for the scientist. Now what will be the answer for this question? How do we classify the elements? Because as more and more elements are discovered, it becomes very much difficult to arrange them in any format. So there is a need of classification only. Before 18th century only few elements are known, but after that there will be a discovery of many more elements. So we have to learn the physical and chemical property of such elements, so it becomes quite difficult to learn the properties of 120 elements. So we need to classify the elements in some order, so it might be easy to learn or to know about their physical property. So this biggest problem needs some arrangement. This problem needs some arrangement, that how they could be arranged so they can easily identified. So this problem has been overcome by having a periodic arrangement of elements in nature, and that is known as the periodic table. So what is actually the periodic table? Periodic table is basically an arrangement of the metals or the elements that will exist in nature in the form of vertical rows and the horizontal groups, so that the horizontal and the vertical groups will going to tell you about the physical properties of the element. So the one solution for this problem is only one, that is periodic table. The one solution for this problem will be periodic table. Now what this periodic table is? Periodic table is actually the arrangement of elements in horizontal and vertical columns and horizontal rows and divided among the periods and group, so that it may be very easy to identify the elements and their properties. So it is actually arrangement of elements in a particular manner so that it may be divided into horizontal rows and vertical columns So it may be divided into horizontal rows and vertical columns. So physical properties can be identified. So this is the basic definition of our periodic table. So here we have discussed about the definition of periodic table. So now, what will be the early attempts for classifying the periodic table? Firstly, the periodic table has been identified on the basis that Lavoisier discovered or classified the periodic table on the basis of metals and non-metals. But after that, in Dalton's trial, Dalton said that they cannot be arranged according to metal and non-metal. They will be the arrangement should be done in the atomic masses, and this thing will become the base for the formation of the periodic table. So what will happen earlier? The scientist named Lavoisier in approximately 1803 said that elements can be classified into two categories, that is metals and non-metals. So this should be the classification for finding out the periodic table, but the idea of the Lavoisier has been discarded by the scientist named Dalton. So this idea has basically discarded by Dalton. So Dalton discarded this idea, and this idea will not be applicable for the formation of periodic table. So Dalton said that the periodic function should be the function of their atomic masses. So he said that it should be function of atomic masses. So if it should be the function of atomic masses, this idea will be the basis for the formation of the periodic table. This idea will be basis of formation of periodic table. So the idea of the Dalton has been applicable for the formation of the periodic table. So this is all about the basic things regarding the periodic table. Now we will discuss about the early attempts for the periodic table. So in the early attempts of the periodic table, firstly we have Doburnier triads. Secondly, we will discuss about the Newland's law of octaves. Then we will discuss about the Mendeleev's periodic table, and lastly modern periodic table, which is accepted worldwide after all these chaos. So let us discuss about the early attempts of the formation of periodic table. So we have early attempts in formation of periodic table. So what are the basic early effects that will lead to the formation of the periodic table? We have categorized this basically in terms of the 4 factors. So the first classification we will going to discuss is about Doburner's triads. This is Doburner's triads. Secondly, we will discuss about Newland's law of octaves. Thirdly, we have Mendeleev's periodic table. And lastly, we have modern periodic table. So, let us discuss these kinds of the early attempts one by one now. We have first classification, that is Doburnier triads. Second classification we will discuss is about the Newland's law of octave. Third one is Mendeleev's periodic table. And the fourth classification we have is about modern periodic table. So these are basically the early attempts of trial, and these all are very important from your exam point of view. So we will discuss these triads one by one. So in this category we have our first triad, that is Doburnier triad. In 1817, J.W. Doburnier tried to arrange the elements in the periodic table, and he arranged the periodic table in the form of the triads. So what he basically considered, he considered that the middle element in the periodic table will be the arithmetic mean of other 2 elements. Arithmetic mean means sum of atomic masses divided by 2. So how Doburnier will perform its experimental setups on the periodic table, let's discuss now. So our first triad is Doburner's triads. Now, what Doburnier take on essential elements or the essential fundamental. So in 1817, J.W. Doburnier arranged elements in the group of 3. He has taken the elements in the 3-3 group, and he called these attempts as a triads. He called them triads. So this will be the general application or the general aim of classifying the elements according to the Doburnier triad. So what Doburnier said about the early attempts of the periodic table, he said that middle element in the periodic table, middle element will be sum of atomic masses of 1 and 2 element divided by 2. So this will be the basis for the classification of the Doburnier triad according to the 3 elements arranged in the group. And simply we can say that third element will be 1 plus 2 upon 2. And here the 1 plus 2 will be the sum of their atomic masses only. So this will be the another formula we have. Now let us have a look at the arrangement of the Doburnier triad. So we have the basic arrangements here. These are actually the Doburnier triads. So you can see easily here, he has arranged the elements in the form of the triad. Triad means there are 3 elements there. So you can see that the 3 elements will be lithium, sodium and potassium. Now what he has done, he has said that the middle element will be the sum of the atomic masses of first and third element. So we will try to apply the formula for sodium. So we can say that here middle element, that is second element. Second element will be first element atomic mass plus second element atomic mass divided by 2. It means this is the arithmetic mean of first and second elements we have seen here. So the first element is lithium, that is 7. Atomic mass for the third element is 39. Here we have to write first and third element. Now it must be divided by 2. So on adding 39 plus 7, what we are getting here, we will get 46. We will get 46. And 46 on divided by 2 will going to give 23. And you can easily see from the table that 23 will be the mass for the sodium. So for this triad, the Daubrinier's attempt has been very successfully done. We can see that the sum of the atomic masses of the first and third element will give us the middle element. So for this, the Daubrinier's triads has been very much applicable. Now let us consider a few more triads of the Doburnier here. Now you can see here is again a 3 elements that are forming triad. Now let us suppose this category, again first and third element, that is 32 plus 128. 32 plus 128, 32 plus 128 divided by 2. What will be the sum? Sum will be 160. 160 when divided by 2 gives us 80. So you can see that 79 and 80 will be similar nearby values. So this 79 will be again applicable. So he has said that these triads are applicable. Now he has tried some more attempts for these triads. Therefore you can see that the sum of the first and third element after adding and divided by 2 will give you the middle element. So you can see that Doburnier triads has been successfully attempted for such these triads. But what is the main drawback of this triad? We will discuss now that why this method is not acceptable all around because of some of the limitations of this triad. So we have limitations of Doburnier triads. So our next topic will be limitations of Doburnier triads. Now the basic limitation for the Doburnier triad is that firstly, this rule will not be applicable for certain elements having the similar atomic masses. So it is not applicable for elements having similar masses. For the elements having similar masses, this method is not adopted. For example, iron, cobalt and nickel. For these elements, this method is not adoptable. Now, second main drawback of this method is that it is restricted, so it is discarded. It is restricted to certain elements. It is restricted to certain elements. So, this method has been discarded. It means this method do not gain much importance because after attempting few triads, this method is not applicable. So, after calcium, this method is not acceptable. Now, for overcoming this method, the second method has been developed, that is the second early attempt in the formation of the periodic table, that is Newland's law of octave. So, let's discuss about the Newland's law of octave.